Alright, welcome back to 19.3. We're going to be going over Explain 1, finding probability using combinations. So really quickly before we move on to combinations, I just wanted to go over briefly what the difference was between permutations, which is what we did on the last one, and combinations. So permutations have to do with arranging people, digits, numbers, alphabets, letters, colors. You'll see keywords like arrangement or arrange or ways. Whereas combinations could deal with selection of menu items, food, clothes, subjects, teams, where order doesn't really matter. It's more of just like, hey, these are the options that I want, you know. You'll see words like select or choice. So keep this in mind. It's in your explain packet, which you get to use, so just keep that in mind when you're kind of deciding, do I use permutations or combinations? I'm not sure. Look for keywords and you'll kind of see some of the word problems actually kind of give it away as well. Alright, so going over combinations, there's an equation that they show us how to find combination. We are going to use our Decimals calculator to calculate some stuff out, but still it's there as a reference for you. Alright, let's go on to Explain 1, where we're going to go over how we kind of find probability using combinations. So let's say there are 4 boys and 8 girls on the debate team. The coach randomly wants to choose 3 of the students to participate in a competition. What is the probability that the coach chooses all girls? Alright, so first things first, the sample space S consists of a combination of how many students can he take. So students he can take to the competition. Well, he can choose 3 out of how many total are there? Well, 4 plus 8 is 12. So that's going to be a combination out of the total for what he can choose or take. It's 12 thirds. And we are going to figure this out on our calculator, but for now let's go ahead and go on to event A. And the event A is that the coach gets to choose all girls. So here he gets to choose at least 3 girls because he's going to take all girls and all 3 spots are going to be those girls. How many total girls are there to choose from? Well, there's about 8. So that would be 8, which is my total that I can choose from out of the girls, and 3 that he could still take. So what we're going to do on our Decimals calculator, we're going to go ahead and show you where this new button is and use it to calculate a sample size in an event A, and then we're going to use that to kind of write in our probability fraction and see if we can reduce it. Alright, so on our Decimals calculator, the scientific one, we're going to write in 12. Go to the function key and write, so actually we're going to clear that. We're going to go to the function key first and press this first. And then we're going to type in 12, comma 3. So there's about 220 that we can choose from. And then again, combination 8, comma 3. That's about 56. So now we're going to write this on our piece of paper for sample size in event A. But since we're here, we might as well also type in our fraction and see if it can reduce it for us. So 56 over 220 reduces to, well, a decimal, or 14/55. So let's write that down on our piece of paper. So that would be 220, 56. Remember, that's 56, our A event. Our sample size was 220, not 222. And with that reduced to 14/55. Awesome. Let's go ahead and go to part B. So part B says there are 52 cards in a standard deck. And we know this because we saw that in the beginning. There are 13 of each suits. So there's clubs, diamonds, hearts, and spades. 5 cards are chosen at random, okay, from the deck. Find the probability that all 5 that we choose are diamonds. So first things first, let's identify our sample size. So there's about, out of the 52 cards we could choose from, we have to choose, according to the problem, we have to choose 5 cards. So out of our total and what we have to choose, that's 52 and 5. Now the event that they want, it says find the probability that all 5 of these cards, because there's all 5, are diamonds. Well, how many diamonds are there? Well, there's about 13 diamonds, right? And you can always refer back to the picture from the Engage if you don't believe me. You can. So this is the total number of diamonds in this case, which is about 13. And the ones that we can take or choose are 5. So I'm going to go ahead and cross this out. We're just going to go and calculate this out. And we're going to use our Desmos calculator to do that. Alright, so again we'll go to our function key and put in combinations. And we'll put in 52, comma, 5. That's a big number. That's like over 2 million. That's a lot. And then we're going to find our sample size for our event, which is, again, function key, combination, 13, comma, 5. That one's still a big number. That's a lot. So let's go ahead and, since we are going to eventually figure out what our probability is, oh, sorry about that. Like I said, since we're going to find the probability anyways, and we have to reduce it anyways, we might as well write in 1287, which is going to be our event A, combination, divided by, what is it, 2,598,960. That is a big number. I'm just going to make sure that I recorded that correctly, because that's a lot. And if we wrote it as a fraction, that's, yeah, I guess it won't reduce it for us. Okay. So we can leave it like that, I guess. Work that out. Alright. That is still, that's a big number, right? So the probability of randomly selecting 5 cards that are all diamonds is about 1,287 over the total possible outcomes of 2,598,960. Just like it says here, stop and do the problems in your packet for Explain 1. We'll come back to do going over homework. All right.